pitch the idea very quick. So it is about formal mathematics in zbMATH Open. So many of you know zbMATH Open. Who doesn't know zbMATH Open? Okay, so I won't skip the slide. So zbMATH Open is a website like Math Reviews that collects publication in mathematics. So we have overall 4.9 million documents, now including preprints from archive. So there is, and 1.2 million of these articles have been reviewed. So some human being wrote a review on an existing article and explained what is the impact of this article for the overall field of mathematics. We have 1.3 authors that contributed to zbMATH. We have 49 million references, links between the articles. We have 46,000 software packages and more than 70,000 links to research data. And in contrast to Math Reviews, we are open since 2021, so that means that everybody can use our website and see what's there, and also request the data via an API. I think Michael, he's not here, has recently developed or one of his group has developed a nice map of mathematics where you can see where the mathematicians stand, and so this can be built based on this data. So we only provide the API, and then people can build their applications about mathematics on that. So we have a lot of visitors, and the visits went up. What we don't have, and that's why I'm talking today, is we have 0 formal statements up to now in zbMATH. So everything is informal, everything is based on text and formally. So that is how zbMATH this animation didn't work as planned. This is how zbMATH looks today. So you have documents and what I said before, software, and there's a formula search thing where you can search for formally, but people currently don't do that. So our hope would be that we could build some formal math input. So, we don't know much more than that we would like to have it, but we don't know how to get to it. So it would be, so for example, I learned on Monday that there is this Louvel system where you can nicely search, at least I could use it directly from the beginning for some concepts, but still I think this search is very specific for the one system. So ultimately it would be nice to have natural language interface. So find all lemmas, row statements, somehow mention the sign function. If you could type that, and then you could translate it to a search which searches formal libraries. So that's what we want to do, and based on what we did previously, we learned that when we try to harvest everything and we say, okay, we build the search engine, we build the technology to find it, it's a scaling problem, and things don't evolve as fast, because we see with formal mathematics, there's a lot of innovation, there's a lot of new technology, so we don't want to build a holistic system that scrapes everything, but we want to build a decentralized system and maybe develop a search protocol that the query can be submitted to different systems that subscribe to a stream and then answer in a certain result format so that we can communicate. There are already some open search standards that could be maybe adjusted for formal mathematics. Yeah. So, and what we also learned from previous approaches, that naming is a big problem. So, and for example, for software, it is not really clear how you could name them, and then the name is changed, and so on and so forth, and who is the author and things like that. So what we would like to use is content addressing. So The idea of content addressing is that you basically use the hash to address things, and then you do some shortcuts, but eventually everything depends on the hash. So you don't, when you would, for example, reference a paper, you would go to the hash of the paper and not to the website of the publisher. Because this then you can make sure that you always end up with the same content when you put that into the system. So we really would like to have some form of stable IDs optimally in the form of hashes to do the search engine and not to rely on things that change this.
So that's a beautiful idea pushed by Chad Brown, but it doesn't work if you have change. So if you minimally change some article, Wikipedia article, or whatever, the content changes, and then you are in big trouble if you have content-based addressing. Like you sort of need to factor it, like you need to, basically you are tracking all the versions, and you need to have some meta system for telling you what are all the versions of that thing.
Yeah, that's a challenge. It always comes with the ID. So, but you can search from this hash for new versions. So, and at least for the things we currently have there, they don't change very often. So change is not the big.
So why hashes instead of DOIs and like?
Yeah, because DOIs they go away. That's what we experienced. And
DOIs go away.
No, the DOIs.
The DOIs stay, but the content goes away or changes. And so it would be. I mean, and for software, I mean, one can do that in addition, but at least one should also consider to have this hashes. So we use in the European Union project here. I have it in the backup. So we archive all the software we have in zbMATH. So whenever you mention a software in a paper, we automatically index the software to software heritage. So it will be like deposited for the time being. And there, of course, there's some names and so on. But the real thing that matters and that is long-term stable is then like a hash from the software. So this is the thing what lasts, and this is really helpful also to reference. And when you want to reproduce your software, then this little changes and corrections, that is what it breaks. So that's the idea of the hash. So what we want to do, so I don't want to spend a lot of time with my presentation, but have some time for discussion, is to develop an idea. So there is a call from the DFG, the German funding agency, that we want to support AI in research through information infrastructures, and that's what we are targeting at. So it's like a first idea. So we want to say, yeah, this idea which I presented here in the beginning, that we get like formal math into zbMATH is something which is useful, and we would describe the idea. And the thing which would be most important to get some partners that know about formal mathematics, because the things that I learned since Monday might be not a good not a sufficient foundation to build such a system. So if you're based in Germany and you're interested in developing this idea a little bit further, so it doesn't mean that you need to do a lot. It's just that we write down the idea and see how this could be implemented. Then I'm happy to discuss it with you and to write this short idea statement, and then the DFG can say if it's like a useful addition to the current IT infrastructure we have or not. That's it.